Hello everyone, welcome back to our Maya to Unity tutorial series. In the last lesson we created we did our transition from Maya into Unity. We created our animation clips. We then brought them into a state machine and made some sub-state machines to help organize our blend trees here. So in this lesson we're going to deal with a couple of issues. One was the walk and run, how like there's no root motion, so when I press play here he walks and he kind of pauses there for a second. Same thing with like our idle here, to where if we want to have it go from idle to walk, that looks alright because he just kind of takes off. But if we go the other way to where it's from walk to idle, he then slides back to the beginning. The reason why is because the root motion in the animation is at the origin and it doesn't take the location into account. So what we need to do is we need to go into the model on the import side and tell it where the root motion is being taken from. So we're going to go back to where it says rig here, and you'll see down here it says root node, and currently it says none. We're going to go ahead and check on this, and since inside of our group root node we have our bone root, that was what is the bottom of our joint hierarchy, we're going to use that so that it can pick where it needs to go. Now some of these might work, but controls probably won't, since the controls didn't come in with it. But let's go ahead and go to the bone root. Okay, and we'll hit apply. Now this should take care of most of it for us. I'll go through all of our clips and say, okay, you're now using that as your root motion. So let's go ahead and try going from walk back to idle now. Let's go ahead and hit play. And there we go, he stops in place, which is what we wanted. Now let's go ahead and go the other way. So let's try walk to run. Let's see if that handles it a little bit better. There we go. There's not that stutter anymore because he just goes straight from walk to run. So that's good. Now let's go the other way, from run to walk. Should be no slide going back. He just kind of goes with it and then right into walk pose. That's great. Okay. So that should handle most of it. So let's also check this one, going from walk to run. That's fine. And let's see about, I think that's actually all of them. Okay. We can probably try out some of these other ones here if we want to, like run to punch. Okay. Don't worry about that little grid that pops up. That's just the grid from the other one. Doesn't do anything. These grids don't render. Okay, so that's all good. The only other thing I want to point out before I cut this lesson short, or cut this lesson off, I know this was a short lesson, is just sometimes you run into a situation where you made this walk cycle, but it's just too slow, or maybe not fast enough. There's this speed multiplier that, as an artist, you can go through here and just, you know, make this higher or lower. It goes into decimal values. It's up to you on what you want this to be, and it will just add that multiplier across the animation. So that should help you kind of dial in your animations to where if you accident it too fast or too slow, you can kind of brute force it back into where you need to be at for your particular game. This is also a public variable, which means that your programmer can also access the speed variable. And since we're using root motion, you can use this to where you can make it to where he walks faster or walks slower or runs faster and whatnot, since you're using root motion to drive the locomotion of your character. Alternately, if you didn't want to use any root motion, you leave that root motion thing unchecked. And you'd also want to make it to where the player wasn't actually having any forward movement. So all that root motion we did inside of our controller, if you weren't wanting to actually go anywhere, you wouldn't just turn off root motion. You wouldn't actually ever have him go forward. You have him kind of walk in place. And then you let the programmers go ahead and animate the forward movement. So that's the alternate way of doing it. Problem with that is that it being programmatically driven is that there is an issue with the programming being too smooth, which creates sliding in the feet. Doesn't look very natural, but it does make it to where it's a lot easier to make sure that he doesn't run into things because it's not being driven by root motion. So there's a kind of like, you know, pros and cons to both sides. But if you want to look the best, go with root motion. That's my recommendation. If you're having some issues with movement and running into stuff, then you might end up having to resort to programmatically driven locomotion. So that's it for today. Thanks for watching, and I'll see you guys in the next lesson.